Welcome to Plutus, and today we are covering exceptions regarding Markovnikov's addition rule. So we have already studied that how Markovnikov addition is used. That whatever substrate that you are adding to a alkene or any unsaturated compound, the negative portion of it will get added to that carbon, which results in a more stabilized carbocation, or the negative portion of the addendum which we are adding will add to that doubly bonded carbon which has lesser number of hydrogen. So in general, alkene is represented as, this is your alkene, and we are taking substitution for it like this. Now, on adding any kind of halogen acids, first will happen is that halogens being electronegative will generate delta positive charge on halogen and will become delta negative. So in this, the alkene being the pi bond in alkene being weak will nucleophilic attack this hydrogen and will generate a carbocation which will be sp2 hybridized. And then this halogen will attack this carbocation and our final product will look like this. Now the problem is this is a very generalized version, that the carbocation that you are getting, it will be attacked by halogen because it is the most favorable part. But the problem is Markovnikov rule do not explicitly ascertain what kind of carbocation you are looking for. Whether it is will be stabilized, it should not be stabilized, can rearrangements are allowed. Those are the things that Markovnikov rules do not take into account, and it becomes its exception. For example, if you have an alkene of this type, CH3, CH, double bond, CH, CH3, carbon, CH3 whole thrice, and this will be hydrogen right here. So let's suppose if you are adding HBr to it, and you are adding HBr in presence of peroxide. So in presence of peroxide, we know that Markovnikov rule will get inverted and this negative portion will attack that carbon which has more number of hydrogens, giving us the product CH3, 3C, CH, H, giving us CH2Br. But in this case, if you expect the product to be like this, CH3 whole 3, C, C, H, Br and CH3, then this product do not form in this reaction as per Markovnikov's rule. So where does this problem lie? Like we stated that Markovnikov's rule do not take into account the possibility of rearrangement to generate a more stabilized carbocation. So here in this reaction, what actually happens is, in this reaction the actual product will be followed by this. First, it will lead to the formation of a carbocation CH3, C, CH3, CH3. This will be a carbocation right here, and this will form CH3. Now this carbocation right here is a secondary carbocation here. So a rearrangement will take place, and this rearrangement will shift this alkyl group to the secondary carbon, generating C, CH3, CH3, carbocation right here. This will be CH, CH3 and CH3. Now here if you look at it, this carbocation is tertiary carbocation, which is much more stabilized than the previous case. So now the Br minus will preferentially attack this carbocation, and our final product will look like this. Our final product will be this. So in this reaction you only get two products, which are like this. Not that one, but actually this one. The Br would be on that carbocation which is much more stable. This is the first exception for Markovnikov's rule. The second rule exists that, but it's actually for peroxide, that the peroxide effect do not works in, effect is not applicable to, is not applicable to HCl. Why? Because the bond dissociation enthalpy required for sigma bond of HCl is very high. Hence, it is not feasible, because the peroxide mechanism goes by free radical mechanism instead of a carbocation. So for that reason, the bond dissociation enthalpy is very high, and this reaction cannot proceed by HCl. So if you are having an alkene, no matter what you do with it, whether you are taking peroxide or not, the reaction will always yield the same product as per Markovnikov's rule. CH2, Cl, it will be CH2, and the same product will be obtained here. CH2, CH2, Cl, hydrogen here and hydrogen here. So these are the exceptions regarding Markovnikov rules. So I hope this would have cleared your doubts why Markovnikov rule is applicable to some particular reaction, in which reactions it is not applicable, what are the reasons where it is not applicable. Okay, so in case you have any other doubts, you can add it to the comment section and we'll get back to you. That's all for now. Thank you for joining us.